Let's deep dive with respect to the interior of our earth. Surface, we have seen that surface is comprised of rocks. But what about the interior parts of our earth? If we go from surface towards the center of our earth, do we have a rocks, or we have a liquid, or we could have some gaseous kind of deposits? We may have these things, but how we can credibly say that yes, this is how the interior of our earth could be? So let us have some practical interaction. Now, if I ask you, tell me what is the nature of our crust, you will say plateau. You will touch the South India's plateau and then you will say it is rocky. Now, if I ask you that the place at which you are standing, now beneath the 12-kilometer depth, what is there? You will say rock. Okay. After 200 kilometer, you will say rock. If I'll ask you after 500 kilometer, you say maybe rock or maybe liquid. So maybe is there. There is no certainty that we could have a different material, different medium, or different matter density could also be there. So what is the practical way to find out that what actually is the structure of? So the practical way to find out about the composition of our Earth's interior is basically the studies, basically the evidences, you can say, basically the direct or indirect sources, you can. So in order to find out that what could be in the deeper parts of our Earth from surface towards the center. So there is a one Kola Superdeep Borehole. So that Kola Superdeep Borehole is basically the deepest man-made hole in our earth crust, which has been created as of now, which has been digged as of now, and it is somewhere 12 kilometers. This is what our capacity. Nature is always powerful. Our capacity is, with the modern science, with the modern knowledge, our capacity is to dig up to 12 kilometers from the surface towards the parts of our earth. Then how can we say what will be the composition after 12 kilometers? In order to find out, we have some other sources, and based on those sources we used to say, okay, possibly this could be the composition of our Earth's interior. So our Earth's surface is rocky, solid. Now what about the interior? So many attempts were made, and I gave you one example of the attempt. We have certain sources. Based on certain sources, we can credibly justify that what could be the possible composition or what could be the possible structure of our interior. So we have some direct sources. And in the direct sources, we have what? Mined rocks. If you mine, you will have a clarity that okay, like up to a certain depth, let's say 2 kilometer, 4 kilometer, 3 kilometer, up to that particular depth, you will say that okay, we are getting rocks, and you have to pay attention that those rocks will be different from the surface rock. Those rocks will have a more density. Those rocks will have a more better refined structure as compared to the surface rocks. So you will say that if you move from surface towards the interior part, the properties of rocks will going to change. The same rocks which we used to found on surface, and the same rock which we used to found at that particular distance. So mining is one of the credible evidence, one of the credible source which actually tell us that what could be the possible arrangement, composition of our Earth's interior up to a certain distance. Then we have a volcanic eruption. See, we have a water tank, and water tank we used to place on our roof, okay, and we have a one tap in our bathroom, or let's say in our kitchen, and when we on that tap, there is a water. So if we have a liquid state, or if we have a magma on the surface, then there must be its source, and that source is in the interior parts of our earth. It's just like that tank and tap. So if that volcanic eruption is taking place, that means there is some sort of source of this volcanic eruption, and that source lies in the interior parts of our earth. That means that there are some layers which are liquid. Which layer we will talk later, but yes, there are some layers which could be at any particular distance, which could be at any particular depth in our earth's interior. Because of that, we have what? Liquid which is actually erupting out. So if you have a liquid while opening the tap, that means the same liquid is also there in the tank. So here in this case, earth is like a tank, and this volcano or this particular we can say narrow vent is like a tap. So when the tap is actually opened, when the eruption is taking place, when the magma or lava, I would say, if it is appearing on the surface, then that there must be a one source of it in the interior parts. It means what? That yes, we have some layers in our earth surface, those who are liquid. So based on these two direct evidences, we used to say that yes, our earth is comprised of solid rocks, and yes, equally our earth may have some sort of liquid composition based on this volcanic eruption study. Based on this volcanic eruption, we can say there are certain indirect sources, and based on these indirect sources, we used to say that okay, this may be the possible composition, arrangement, structural arrangement of our earth's interior. So first of all, we have what? We have change of temperature, pressure and density. We have what? Change of temperature, pressure and density. I hope you remember about the theories which we discussed in our previous session. There was a one particular thing, and what was that one particular thing? That towards the center part, towards the core part of disk, there was more density, and when there was a more density, the temperature was greater, and specifically on the outer part of those rings, we have what? Lighter material. Similarly, we have what? Earth. Earth is like a part of that particular nebula, we can say, and as a result of that part, what we can say, that towards the center part of our earth, or when you are moving from the surface towards the central part of our earth, it means what? That it means the density, rocks, density of rocks would going to increase. It's because of the temperature, it's because of the compaction which is taking place at the core part. One more thing is there, that when we actually dig this Kola Superdeep Borehole, we dig up to 12-kilometer depth. Why not beyond that? It's because that at the 12-kilometer depth, there was no material which can stand with that temperature which is exceeding 100 degrees Celsius. So whatever equipments, whatever drilling equipments which we have nowadays, those equipments cannot sustain at this 100 degree or 120 degree temperature. In general, when you are moving in the interior part of our crust, at 1 kilometer, you will see that the temperature will going to increase by 25 degrees Celsius. Means if you are on surface and the surface temperature is, let's say, for example, 20 degree. Okay? And if you move in the interior part of our earth, from the surface you are moving towards the center, and you have traveled a distance, or let's say depth of 1 kilometer, then here the temperature would be around 45 degrees. Even after 1 kilometer, the temperature would be like almost, we can say, close to 70 degrees Celsius. Okay, 70 degrees. If you move further 1 kilometer, so it would be like almost 90-95. So this is what a usual rate in which the temperature actually increase when we are moving from surface towards the depth. So while digging this Kola super deep borehole, we got to know about this pattern of temperature, that yes, from the surface, if we move in the interior, temperature will going to, and temperature will going to increase in this. So that's the first thing. Second thing is what, that when we dig this mining, we got to know about this different density of rock. So it suggests that yes, from the surface towards the center, the density pattern of rocks will be completely different. Yes, density is also increasing because of the temperature as well. Temperature factor is also there, and both temperature and density is basically indirect source. Especially pressure is also there, that when there are large strata of rocks, and suppose we have a strata of rocks in this, here we have A, B, C, D, E and F. So on this F rock, there is a huge pressure of these overlying rocks. So it's because of this we have a more temperature, and because of the more temperature we have a more density, and ultimately what we can say, we have a more pressure. So these characteristics basically provide us a one insight that yes, this could be the possible composition, which is basically changing density or changing temperature pattern. Next one is meteors. When there is a meteor, if the meteor, now you will say meteor is basically like a celestial body, it is not found on the earth's surface. Yes, certainly, but when the meteor is there in the space, and if that is entering into the atmosphere, meteoroids we can say, and if it is, suppose somehow if it is there on the earth's surface, yes, we have some meteoroids, those who have arrived on the earth's surface. One was there in the Russia, and recently during the COVID we had a one part of meteoroids which actually landed in Gujarat. Okay, so when that was landed in Gujarat, so scientists rush up, they go for that particular meteoroids, and they carried out study just to find out that if the same pattern is reflected in meteoroids, that whether the density of rocks is same or different. So this give you a one idea. It's because Earth, meteoroids, all of them are actually comprised of that particular nebula, are believed to be a part of that nebula as of now. Okay, that all of them are believed to be a part of sun, whether it is meteoroids or whether it is Earth. I hope you remember that planetesimal theory of Chamberlain and Moulton. So meteoroids also give us insight that that could be the possible way of the other celestial bodies of and about their composition. So in the same way, Earth could also have a same kind of composition. Similarly, we have a gravitational and magnetic fields. Gravity, it is there. Magnetic fields, they are also being there, and you might have some sort of understanding about geomagnetism, that our Earth used to show a one pattern of magnetism, behavior of magnet. You might have seen that compass and all. So based on that, what we can say, that the magnetism which is there, our north pole and south pole, and this is what the magnetism or magnetic area which is surrounding the Earth. This area is very much vital as far as the satellite communication is concerned, as far as the navigation is concerned, as far as the scientific aspects are concerned. So why do we have these gravitational, or let's say this, it's possibly because of some magnet which is believed to be in the Earth. So when we have a magnet, so whether it is solid or liquid, so that provides some sort of evidences that yes, there might be a possibility that we could have a solid magnet or liquid magnet. Because of that, we have what, this magnetism surrounding the Earth, and this magnetism used to protect us whenever there is a solar flare. Solar flare is like a solar storm, just like a cyclone we used to see. So it is a kind of storm which is arising from the surface of sun and moving towards the other planet. So when it is about to interact with the earth, so this magnetism used to save us from that solar flare. And this magnetism is basically the result of either liquid or solid magnet, which is believed to be in the part of our earth. It means what? That some part of our earth could be solid or some part of be liquid. It possibly suggests us. Okay, which particular part are there? We don't have a credible idea on that as per this particular aspect, and as of now I am telling. Okay, then we have a seismic activities. We have a seismic waves, we have a seismic activities, and these activities are basically the result of catastrophism. Earthquake is there. So whenever there is an earthquake, seismic energy is released, and this seismic energy is responsible for telling us a pattern to find out that what could be the possible composition of our earth's interior. So currently and as of now, this is one of the most reliable evidence which actually provide a insight on the interior composition of our earth parts. So let's see what is all about these seismic activities are there. So what we can say, before that, let's have some generalized overview about the interior of earth. Then we will surely get to know about these seismic activities, that what are the seismic waves and what ideas has been provided by these seismic waves as far as the interior of our earth is concerned. Okay, so we are just stopping this aspect here. We are starting with the interior part, its composition. Then later we are going to have a deep dive on these seismic activities, and we're going to understand that how our earth's interior is there based on that seismic wave study. Okay, I told you in geography there are small concepts, and when you have a clarity of 1 2 3 4 concepts, then you can join all of them. Further, that become a separate concept. Along with that, there will be some other topics. When all of them are joined together, they will act as a one single concept. So they are very small concepts. You can only able to understand whenever you will take all of these concepts parallelly. Simultaneously you have to understand. Okay,